In this tutorial, we'll be looking at calculating the standard deviation. Recall that the standard deviation is a measure of the risk of a project. There are two scenarios in which you'd have to calculate the standard deviation. There are scenarios where you have to calculate the standard deviation where the probability of each possible outcome is equal. Then there are scenarios where you have to calculate the standard deviation where the probability of each outcome is not necessarily equal. So we'll have a look at the calculation for each of these two scenarios. So in this example, we've got asset A, and asset A can give you the following returns. It can give you 7%, 10%, 18%, or 13%. All of these returns are equally likely to occur. So we can now work out the expected return as follows. The expected return of asset A is the addition of all the possible returns, and since these are all equally likely to occur, we divide it by the number of data points, and that's 4. So that gives you 48% divided by 4, which gives you an expected return of 12%. Now, to calculate the risk associated with asset A, in other words, the standard deviation, you first need to calculate the variance. You calculate the variance in the following way. You take the squared deviations of each data point and the expected return. So it's the difference between the data point of 7 minus the expected return of 12%. We square that difference. 10 minus 12 squared, 18 minus 12 squared, and 13 minus 12 squared. It's worth noting that we square these deviations because these negative differences will turn into a positive. So negative 5 squared gives you a positive 25. Negative 2 squared gives you a positive 4. Positive 6 squared gives you 36. And positive 1 squared gives you 1. So if we add all of these up, it gives us a total squared deviation of 66. Now the variance is equal to the sum of the squared deviations divided by the number of data points, which is 4, and this gives you a variance of 16.5. However, we're not looking for the variance, we're looking for the standard deviation. So the standard deviation is simply just the square root of your variance of 16.5, and that gives you
4.06%. Let's move over to the second scenario, where exactly the same, the only difference being that the returns are not as equally likely to occur. So we work out the expected return as follows. It's the probability of occurrence of each return multiplied by that associated return. So it's 0.3 multiplied by 7% plus 0.2 multiplied by 10% plus 0.4 multiplied by the 18% return plus 0.1 multiplied by the 13% return. So this gives us an expected return of 12.6%. If we are to work out the risk associated with in this scenario, we again need to take the squared deviations. So the 7%, 10%, 18%, and 13% are all your possible outcomes. We minus each one from the expected return of 12.6% and we square that. So the second one would be 10% minus the 12.6 expected return squared. The third one would be your 18% possible return minus the 12.6 expected return, again squared. And then the last one would be 13% possible return minus the expected return of 12.6%, again squared. The difference here, however, is that we've got probabilities associated with each deviation. So we need to incorporate those probabilities. So the first one we multiplied by its probability of 0.3, the second one is multiplied by 0.2, the third one is multiplied by 0.4, and then the last one is multiplied by 0.1. This equates to the following values. The first one is 9.41. The second squared deviation multiplied by its probability gives you 1.35. The third one gives you 11.664. And then the last one gives you 0.6. The summation of this gives you your variance. And the variance amounts to 22.4. But we're not looking for the variance, we're looking for the standard deviation. And the standard deviation is simply just the square root of the variance, which gives you a standard deviation of 4.74%. At this point, it's worth noting the similarities as well as the differences in calculating standard deviation in each of these two scenarios. It involves the calculation of the expected return, regardless of which scenario you're faced with. The expected return in scenario 1 was just the summation of all the returns divided by the number of data points, whereas in the second scenario, we multiplied each return by its probability of occurring, and we summed these all up in order to work out our expected return. The second part for both scenarios is to calculate the squared deviations. So each data point is taken and deducted from the expected return, and whatever that value is squared in order to negate the situation where the differences and the negative differences cancel one another out. The third step involves calculating the variance. So the variance is calculated by taking the sum of the squared deviations and dividing it by the number of data points. Whereas in scenario 2, we calculate the variance slightly differently. Each of the squared deviations is multiplied by the probability of occurrence. And that will give us our variance. Step 4 simply just involves taking the square root of whatever the variance that you have calculated is in order to calculate your standard deviation.